recording. Okay.
All right, I'm group 18, and I'm going to present you the super resolution multi-shot neural talking head synthesis. So our main problem was to compress data for video conferencing. So as you know, like right now in COVID, a lot more people are using video conferencing, which is great. We're able to see our face, but video is one of the most bandwidth expensive type of data. So we thought we might find a way to reduce and compress this data. So the baseline of our problem is like the neural talking head synthesis method, which just take a single source image as an appearance and a driving video from where we extract expression and head pose to reconstruct a video. With this, we can do like deep fakes of the person, or like the face vid-to-vid paper did. We can use it for video conferencing. As you can see on the top right, they compare it to H.264, which is the basic video codecs used right now, compared to their method. And using the same bitrate, low bitrate, their method is much better than video. Then super resolution is a great tool for compressing data, because with a good model, we are able to send a very low quality image through the internet and upscale it at the other end. So for that, we choose to use ESRGAN with the enhanced SRGAN version, which is a pre-upsampling super resolution model. Here is our solution main ID. So here you can see kind of the data flow of the one-shot neural talking head synthesis model, which is the face vid-to-vid model I talked about earlier. And what they did was put an input video from which we can extract facial feature, as well as one single source image that are both sent theoretically through the internet, and then input to the face vid-to-vid model, which can reconstruct the video. Our new version is a super resolution multi-shot. So from a single input video, we will now extract multiple source image at a certain frequency. And before sending them to the internet, we can downscale them back to 64 times 64. And on the other hand, use the ESRGAN model to use super resolution on them and bring them back to their original size. And another change is that now face vid-to-vid model is able to process multiple source images. Let's see our result. So let's go into details. On the left here, you can see the original implementation with a random source image from the video. And on the right, one of our methods without the super resolution and a frequency of 10, which basically means each 10 frames, we get a new source image. We can now compare the same parameters on the left without super resolution and with super resolution on the right. The main difference brought by super resolution is that for now, we don't have like a temporal continuity. You see there are some like teleportation, we could say. That is a problem we'll need to fix in future work. Of course, we can use as many frequency value as we want. And to see what are the impact of frequency value, we make the following graph, which basically represents the total byte transmitted to reconstruct the video for a 600 frame video based on frequency. So the horizontal red line is the video codecs H.264, which is around 10 megabytes for 600 frames. And in green is the original implementation, which is about 100 times less. And in blue and orange are our new models. The orange one is the one without super resolution. So of course, we'll have to send more transmitted data because we are sending multiple source image. But what's interesting is thanks to ESRGAN and the fact that we send lower quality images, we're able to still send the same amount of data with this breakpoint frequency and like be able to send multiple source image without sending more data. And we can compare the result with, on the left, the original video, in the center, the original implementation, and on the right, our solution with super resolution at this breakpoint frequency. Thank you for listening.
Any question? So I have a quick question. So
Sure.
you just showed the examples, and they look actually very similar. So do you
Yeah.
have any mechanism to compare these quantitatively?
The original implementation had some, but it was pretty hard to implement right now, so we didn't took much time to do it. But actually, right now, we only like basing our result on visually mainly, which one seems better to you. But of course, if we had more time, we could have used a certain criterion to give a value to the result.
Okay. Thanks.
Thank you.
Mm-hmm.